Hey guys, and welcome back. One more paper until you're completely finished with GCSE Maths forever, at least hopefully. I have the paper 3 for the aiming for grade 9, and some of these questions are really interesting. As you guys may be aware, in paper 1 and paper 2, the style of question was a bit different than usual. So what I've done is I found some questions that are also a bit different than usual. So we can go through them and see exactly how well we can do. So again, the maths may not be too tricky, but remember it's the problem solving and the application which is really going to separate people from getting grades 7, 8s and 9s. So without further ado, let's just jump straight into it. So for the first question, it's probability, but specifically it's Venn diagrams, and it's a 4-marker. The reason why I say Venn diagrams is because realistically, if you look at this, it's not really possible to do this in your head, or at least I would very much struggle to do it in my head. So all you have to do is draw your 3 intersecting circles. So again, draw them as big as possible, just so you can have a lot of space. And let's just call it, so it's what, tea, coffee and milk. That's an interesting selection of drinks, but whatever. Box around the outside. And then all I do is I normally just read it from top to bottom because they normally give it in a very nice way. There's 50 people and it says all 50 people like at least one drink, which means there's 0 people on the outside. And tick it off. 19 people like all 3, so that'd be right in the middle, 19. 16 people like tea and coffee but not milk, so that means there's 16 in the overlap between tea and coffee, but not milk section. Remember, this whole section here is tea, milk and coffee, any combination of those, but tea and coffee only is going to be right there. 21 people like coffee and milk, so again the coffee and milk would be this overall section here, but we already have 19 people who like all 3, which means there are 2 people who like just coffee and milk. So bear in mind, again, the reason why it's different for this one up here compared to the 4th one is because this one, it specifies they don't like milk, so we don't include this number. In the next one, it says 21 people like coffee and milk. Well, there's 2 people that like coffee and milk only, and there's 19 people who like tea, coffee and milk, but that still includes coffee and milk. 24 people like tea and milk, so that means there'll be 5 people in that outer area. 40 people in total like coffee, so all I'm going to do is be a bit lazy. 40, take away all of these numbers, minus 2, minus 19, minus 16, gives me the remaining people 3. And 1 person likes only milk. Okay, good. Now all we need to do is add up all of these numbers, and whatever's left over is going to be the number that's in tea. So we have 1 plus 2 plus 15, oh, not 15, plus 5 plus 19 plus 16 plus 3. That brings us to 46. Which means it's 4 people that like tea only. Now the way that this works, the marking scheme, is you start off with the 4 marks and you lose a mark for every incorrect number, number that's missing or number in the wrong place. So not putting the 0 out here would cost you 1 mark. Now, work out the probability the person likes tea if we pick one of the random 50 people. Well, all we do is we add up everyone inside the tea circle and we divide it by the total number of people. So it's going to be out of 50, I'm going to do 4 plus 16 plus 19 plus 5. And then work that out. I do like to write my working out just so I can get those method marks in case I make a mistake, because as you guys have seen before, I am prone to it occasionally. 22 out of 25. A question that I got asked pretty consistently in the comments for the last video is how do I avoid making silly mistakes? The way I would do it is A, take it very slowly. So I'll go through and I'm very carefully doing each step to make sure I don't make a mistake in the numbers or the signs or whatever. The other thing is, in your head, try and explain it to someone else as you're doing it. So, okay, 40 people like coffee. Well, that means that all these numbers need to add up to 4. And that, again, don't say it out loud, otherwise you get disqualified. But if you say it in your head, it can really help. Now, given that the person selected at random likes tea, this is a really important thing. Find the probability that this person also likes exactly one other drink. Now, that means that the number we're looking out of is going to be the number of people that like tea, which is 4 plus 16 plus 19 plus 5, which is 44. Yes. Because it says given that they like tea. So that is a given. So it's out of this circle here. Find the probability that they like exactly one other drink. So in this big circle, which numbers represent one other drink? Well, it's not the 19, it's the 16 and the 5, because the 19 is 2 other drinks. So 16 plus 5. And again, I would just use a calculator. I mean, I know it's 21 over 44. Okay, yeah, you can't simplify it, figured. Okay. So yeah, that's it. Not too bad overall, but again, given that part can be a bit tricky for some people. I really like this question because function machines are technically grade 2 or 3. Now before we skip ahead, I want to point out that this isn't actually function machines. And that might sound a bit weird, but if we read it for just 1 second, two function machines A and B, so we have these two things. Both machines have the same input. Work out the range of input values for which the output of A is less than B. Bit trickier, right? Because this isn't actually function machines. The way I would do this, and again this is a question I haven't really seen before, is I would write A and B in terms of algebra. So, we take an input, which we're just going to call X, and if you want we can call the output Y, but it's not really going to make much of a difference. We square it and then add 6. So this top function machine is just x squared plus 6. That's it. If you'd like, if you want to be really technical, it's technically y equals. But anyways, this next one is subtract 3 and then square it. So again, it says the input is the same, both x. So it's going to be minus 3 and then square it. And that gives you your output. So again, technically y equals. Now, what does it say? It says work out the range of input values, so the range of x values for which A is less than B. So in terms of what that means is this top equation is less than the bottom one. So if I make them not equal to each other, make an inequality, that means x squared plus 6 should be less than x minus 3 squared. That's what you're actually solving. Pretty interesting, right? It's not a normal function machine. Although it's a function machine, which is like grade 2, it's actually quadratic inequalities, which is a bit of a harder topic. In fact, quadratic inequalities is grade 8 or 9. That's why I kind of like this question. So, hopefully no one skipped it anyway. So yeah, that top one is less than this one. So again, expand, simplify, blah, 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 all that fun stuff. So we have x squared plus 6. If you were to expand this, you get x squared minus 6x plus 9. Then I would probably move everything to the... Oh, actually, no, it's not even quadratic. It is quadratic inequalities, but we won't need it because if we minus x squared from both sides, it gets rid of it. I'm going to move everything over to the left-hand side. Okay, let's do that. So minus x squared from both sides plus 6x. And then minus 9 from both sides, less than 0. So 6x is less than 3. So x is less than a half. That is the range of values for x for which the top function is smaller than the bottom one. Interesting. So although it is a quadratic inequality, the quadratic actually cancels, which is really handy. But again, that's a super interesting question because it's not normal, right? This is a very different way of putting it, putting a quadratic inequality. So again, with this paper, there's another function machine question because again, they are slightly tricky questions. So treat this more like a, what are the weird style of questions that could come up. So we have a function is represented by the following function machine. A number is input into the machine. The output is then used as the new input, and the second output is 11. First, find out the number that was the first input. So basically, what they've done is they put in a number. I don't know what the number is. I'm going to call it x. You can call it n, y, whatever you want to call it. We times it by 2, so that's 2x. And then we add 5, and that's our output. So that's the first output, right? However, they then take this number and they sub it back in again. So now we're timesing this whole thing by 2. So it's 2x plus 5, and that should equal 11 because of this statement here. So if we expand that, I'm actually going to write this up here because I've run out of space. We have 4x plus 10 plus 5 equals 11. 4x plus 15 equals 11. 4x equals minus 4. So the original input was negative 1. That, again, is not easy. Even though the function machine's like grade 2 or 3, it's a pretty tricky question because, again, it's about, well, it's a function question, but it's about applying the knowledge. The maths itself isn't too bad once you know what you're doing, but I hope that makes sense. If not, again, leave a comment. I'll explain it again. This is another interesting one. a number is input into the machine and the output given is the same number that was put into the machine. So in other words, if I go back to this part, we have this input x, we times it by 2, we add 5, and what do we get? We get the original number x. That's what that sentence is saying. So we put in a number x, we get out the same number x. What is that number? Well, again, I just make an algebraic equation. Minus x on both sides, we get x plus 5 equals 0. And then we have x equal to minus 5. Not bad, right? Not super easy, but again, once you know what you need to sub in and once you know what equation you need to make, it does become a lot easier. This one's another one that's really funky. I think this is the last functioning machine question, so don't worry too much. We don't know what it's timesing or subtracting by. Interesting. If the input is 3, the output is 5. If the input is 7, the output is 25. So we have 3, 5, 7, 25. And we need to find the boxes. Now, I know for a fact there's people out there that are going to say, let's use trial and error. We're mathematicians, right? We should be using equations. If I don't know a number, what do? Well, I just replace it with a letter, A and B. Now let's sub it in. We have 3 times A, so that's 3A. Take away B equals 5. That's our equation. Then we have 7 times A, so 7A. Take away B equals 25. That's our second equation. 2 equations, 2 unknowns, guys. Simultaneous equations. So a question that I actually got asked, I want to pause for a second, is if simultaneous equations has already come up, can it come up again? Or if quadratic equations have already come up, can it come up again? The answer is yes, because this isn't a simultaneous equation question, really. It's about functions. But you have to use simultaneous equations to solve it. That's why in previous videos when I've said that algebra makes up like 50% of your grade, it's not because there's 50% algebra topics, it's because solving questions in total will be about 50% of your marks. In this case, the number in front of b is the same, so we can just do subtract, because same sign subtract, opposite sign add. So we get minus 4a equals minus 20. Divide both sides by minus 4, you get a is equal to 5. Summing it back into, let's just do the top equation, we have 3 times 5. In fact, let me sub it in properly just so you guys are fully okay. We get 15 minus b equals 5. Minus 15 from both sides, so minus b is equal to minus 10. So that means b is equal to 10. Now, do I need to fill in the boxes with my new number? I actually don't, because I have a and a equals this, b and b equals this. But if you're really paranoid like I am, I would just put 5 and 10 into those slots. And again, with trial and error, could you do it? I guess so. But it'd be very tricky because you have 2 different equations to try and do it, right? Like, just because you get one that works with 3 and 5 doesn't mean it'll work with 7 and 25. So you got to be careful with that. Another fairly interesting question. It kind of looks like iteration, and technically it is. Remember, iterations are all geometric progression. So we have Louise and Tara are investigating the growth of a population of a type of bacteria. They have 2 flasks, A and B. At the start of day 1, there are 1,000 bacteria in flask A. The population grows exponentially at a rate of 50% per day. Show that the population at the start of each day forms a geometric progression. So geometric progression means it's times by the same number each time. A 50% increase is equal to 150% each day, which is equal to 1.5 times. So in other words, if I wanted to create an equation, a geometric progression, I'd say Pn plus 1 is equal to 1.5 Pn, which is geometric. If you want, you could write this in words. So it's geometric because there is a common ratio of 1.5. That would also work. For part B, the population of bacteria in flask A at the start of the 10th day is 10 times the population in a flask A at the start of the 6th day. So what I'm going to do is I'm going to work out how many are in day 6 and how many is in day 10, and then just divide the 2 numbers to work out what K is. So how would I do this? Well, I would use my iterative formula. So 1000 equals and then just sub it in. So 1.5, and then I'm paranoid, so I like to use brackets. But that will give me day 2, day 3, day 4, day 5, day 6. So we have 7593.75. You should round it up because you can't have 0.75 of a bacterium. Now I'm going to go a few more days just to get to 10. So that's day 6, day 7, day 8, day 9, day 10. So 38,443, I'm going to round that to. 8443. So then k is just equal to those two numbers divided by each other. Another thing I've noticed, especially in exams, is a lot of students, when they don't recognize a question, as in the process, they shut down completely. If, in general, this might help, if you just try and follow the instructions given to you, that's the best way to do it. Don't try and think, oh, what question have I done that's similar to this? I know a lot of teachers give you that advice, but instead if you read this, 10th day is k times the 6th day. So in my head I'm thinking, okay, I need the 6th day and the 10th day. That's logical. That way it does make it slightly easier for you. Again, the maths here isn't difficult, that's not the problem. The problem people would have with these questions is they wouldn't know what to do in the first place. Which I totally get, I do agree with you there. These are very odd questions, and as you guys know, the papers have been very odd this year, which is why I really like, oh god damn it, which is why I really like the this paper, because it's not challenging in terms of the maths, it's challenging in terms of the application. So k is going to be, it doesn't say it's an integer, I'm just going to say 5.06 to 3SF, just to keep my sanity. Okay. The last part is very interesting. This would actually be probably 2 marks in the real exam. But at the start of day 1 there's 1,000 bacteria in flask B, but it grows at a rate of 30% instead. So this is kind of interesting because we have to sketch a graph to compare the size of the bacteria, the population of the bacteria in flask A and flask B. So what I'm going to do is, you could put them on the same graph to make it really obvious. So that would probably be my recommendation, because it doesn't specify you have to give it on separate graphs. Now, here we're going to have the number of days. They both start at a population of 1,000. But what's the difference between A and B? Let's do A in black and B in red. And B in... Actually, yeah, red. Why not? Red's a good colour. Let's make the thicknesses the same just to make it a bit easier. So, because this is increasing at a rate of 50% per day instead of 30% per day, it's going to be a hell of a lot steeper. So you're going to have something that looks like that. Whereas the red one, it's going to start off very similar, but it's going to be a lot shallower over time. If any of you are interested in like business and finance, things like that, that's why kind of if you're looking at like compound interest or like rate of return or whatever, a few percentage points actually makes a huge difference in the long term. But yeah, that's all you'd need to draw. It won't start at 0. That's why I said there's 2 marks, by the way, because 1 mark for not starting at 0, another mark for making sure that line B is shallower than line A. That would be your 2 marks for that. Here we have an actual iteration question, finding 2 and 3. Again, I don't think this is too spectacular at all. But part B is a bit more interesting. It says work out the solution to 6 decimal places. That is actually slightly interesting. So I'm going to do -1 equals, then I'm just going to sub in that formula. So we have answer to the power of 3 minus 3 over 8. So that's, okay, that's fairly easy. Minus a half. Minus 25 over 64. Cool. Now finding the solution to 6 decimal places is interesting, because what you're going to do is you're going to keep going until the number does not change at the 6th decimal place. So if I do this, we have 1, 2, 3, 4, 5, 6. Basically I want to keep going until that 6th decimal place will not change if I round it. So honestly the thing I would do is I would just keep pressing equals, and can you see how the number's not changing anymore? That's all I would do. Since it's 1 mark, you don't need to show any working out. So that would be -0.38, whoops, 381966. In A-level maths, if any of you are doing A-level maths, you do have to show the working out, so you have to write down the values and then show that they round to the correct number of decimal places. But since we're not doing A-level maths, I'm going to leave it like this. By completing the square, again, fairly interesting because it's a calculator paper, but the completing the square formula is if you have something that looks like this, x squared plus bx plus c, equals 0, I guess, technically, but you don't need to have the equals that. It's x, and then you just have your b over 2 term. So plus b over 2 squared minus b over 2 squared, and then the plus c at the end. So let's do this. We have x minus 2 squared, that's meant to be a minus, there we are, minus 2 squared minus 3 equals 0. And by the way, this is actually a really good point, is whenever students tell me about kind of completing the square and all of this, and do you have to be able to solve equations using completing the square, the answer is absolutely. Because they can specify. If you use the quadratic formula in this case, you get nothing. If you use factorization, which you can't, but if you hypothetically did, you get nothing. They can specify which method to use, because remember, the point of an exam is to test what you know. It's not just, hey, do you know how to solve quadratics? It's, do you know how to solve quadratics by completing the square, factorizing, quadratic formula. Anyways, enough of the lecture. We have minus 4 minus 3 equals 0. There's a square there. So that's x minus 2 squared minus 7 equals 0. That's x minus 2 squared equals 7. Up here, square root both sides, you get x minus 2 equals plus or minus root 7. And then x is equal to plus or minus... to be honest, there's a few different ways you can write that. You can do it like this, or you can do it as 2 plus or minus root 7. Which does look like the quadratic formula form, if you would like to do it that way. Show that it has no real roots. Interesting question. There are two ways to do this. One is the quadratic formula. The other is using completing the square as well. Again, if you guys are doing kind of either further maths or you're doing the international exams, there is another way for you guys, but I'm not going to mention it in this video. So, show that it has no real roots. Technically the equation would have to have an equals 0, but that doesn't matter too much in this case. That means there's no solution. So one way, absolutely, is to use the completing the square equation. The other way is to use the quadratic formula and show that the thing inside the square root is a negative number, because you can't square root negatives. So I'm going to, what will I do? Let's do the, okay. I would say the completing the square formula is actually quicker because you get to the square root faster. So you'll realise that you need to square root like negative, what would it be? Negative, not 13, but it'd be like negative 20 or something like that. Or whatever, and you won't be able to do it. But I'm going to show you using the quadratic formula because it's a different way of doing it. Quadratic formula, minus b plus minus square root b squared minus 4ac over 2a. Technically you only need to do this bit, but let's just do the whole thing. We have minus 7 plus minus the square root of 15. And again, all I'm really trying to show is that the thing inside, because if you, and okay, how do I know that that's how I know that there's no real roots? Well, if you think about it, this can never be impossible, right? It can be any number. This can be any number except 0, but if it's 0, then that means there's no x squared, which means there's no quadratic. The only thing that can cause issues is the square root. It's the only thing that can give you a math error. So we can just solve the whole thing, it's fine. Plus minus square root. And then I'm going to just work out what this is. I'm not even going to use my brain because that's scary. Let's just use, so that would be, I was going to take a shortcut, but I decided against it. We get negative 3. Now again, it's your conclusion that's important in this case. Cannot square root a negative. Square root negative. Therefore, no real roots. And that's all you'd have to do for that. Another sort of iteration question that could come up is where they just give you an equation, they ask you to use iteration to find the positive root. The only way to do this is to first make it equal to 0, because of course roots are when the expression equals 0. and then you need to rearrange for the highest power. So I'm going to move everything over to the other side. So we have x squared equals minus x plus 5. Square root both sides. And that is now my iterative formula. And it says, find the positive root, giving your answer to 5 decimal places. So we need to decide what our starting position is. So let's say xn equals square root plus 1 minus xn plus 5. We need to choose a starting position and then once again do the same process we did back here where we just do it a billion times until it stops changing. But overall, that is all you need to do for that question. So since we're taking a positive root, it makes sense to pick a positive number. So why don't we just pick the smallest positive number, which is 1, to do our formula. So that's our answer now. We have square root minus answer plus 5, and then we're going to, whoa, what happened there? Plus 5. Go like a million times until it stops changing to 5 decimal places, which is like here. 1.79129. That took me a second. 1.79129. Job done. Next thing is the Fibonacci sequence, which honestly it doesn't come up that often, but it is somewhat interesting in my opinion because it is a bit different. The rules for Fibonacci sequence is you take the previous two terms and add them. So for example, to get 2, they've done 1 and 1. To get 3, they've done 1 and 2. To get 5, they've done 2 and 3, and so on. So finding the 9th term, well, we have the first 6 already. So the 7th is going to be 8 plus 5, which is 13. Then it's going to be 21, and then it's going to be 34. Jesus Christ, that's basic maths. 3, 6, 9. So yeah, 34 should be the answer for that one. Same thing with algebra. So when it comes up in terms of just letters, it'd be a plus b. The next one will be a plus 2b, right? Because it's a plus b plus another b. Then it's going to be a plus a, so 2a. B plus 2b, so 3b. And then lastly, 2a plus a is 3a. 2b plus 3b is 5b, as stated in the question. Lastly, it says, given that the third term is 7 and the 6th is 29, find the values of a and b, simultaneous equations. So the third term is a plus b, so we have a plus b equals 7. And the 6th term we have 3a plus 5b equals 29. So I'm actually going to write these the other way around because I want the bigger one on top, just because it makes more sense to me. I'm going to make the a's the same, so I'm going to times the second one by 3. So we have 3a plus 5b equals 29 still. But then we have 3a plus 3b equals 21. Subtract, you get 2b equals 8, so b equals 4. Sub that back into the second equation. We have a plus 4 equals 7, so a is equal to 3. So we have 3 and we have 4. That's all you've got to do. You may notice I've jumped ahead on a few of the questions. Honestly, the ones in between were not that bad. It was like factorizing and doing something like that. Because again, remember, in a normal paper, you're not just going to have grade 9 questions. So I'm pretty sure everyone's fine with this, but if not, leave a comment and I'll respond to it. But these questions we've already done a bunch of. But this, however, is a bit more interesting. So we've got to more of the geometry style. So ABC is a triangle with AB equals AC. So these two sides are equal to each other. And BA, where's BA? BA is parallel to CD. Okay, so this is okay, I've already seen what we have to do. Show that angle X is 30 degrees. Well, the first thing I noticed, by the way, is because this is one giant Z angle, right? So this angle here and this angle here are the same. Because, I mean, it looks like a Z if you look at it from the side as well. Now, what I would do next is, because we know some of the values already, we can use that to work out the answer. So we know that this is 90 degrees, for instance. Now I could use this bottom triangle to work out the angle at C. Now some people ask me, how do I know what to do? It's not really that I know what I'm doing, which sounds a bit bad for a teacher, but it's more that I'm just working out the stuff that I need to work out. Okay, so I saw that I couldn't really work out anything else, so then I noticed that would be 90 degrees, and I've noticed this. So it'll be 180 minus 90, which is 90. 90 minus 15 is 75 degrees. And I do know something else. It tells me that AB and AC are the same. which means that these two sides are the same, which means this is an isosceles triangle. So that means this side here is also 75 degrees. Now there's two ways to do the next part. One way I could do it is I could just do x is equal to 180 minus 75 minus 75. Another way is I could work out the inside bit of this angle and then work out x from there. So either way you can do whichever one you really want to, but in general x minus 75 minus 70, oh, what am I doing? Sorry, plus 75 plus 75 should equal 180. So that's x plus 150 equals 180, and then as stated, x is equal to 30 degrees. And it should work if you do it the other way. So you have 60 plus 90 is 150, x is equal to 180 minus 150. So yeah, even if you use the inside bit is just 60, that would also work. 3 marks. Not too bad, but it's not too easy either. But again, in geometry questions, just work out any side, any angle you can, and use that information. So we've used all of this information to work out that answer. ABCD is a rhombus. M and N are points on BD such that DN equals MB. So I might just say that DN equals MB straight away. We need to prove that DNC. So let's draw this in red. And MBC, or sorry, BMC as they put it, are congruent. So they are identical triangles. So we've already done one thing. We've said that MB equals DN. But what else? Well, it's the other things we need to talk about are the special facts about a rhombus. So a rhombus is a parallelogram with all sides equal. So what that means is that DC and BC are actually the same length as well. So DC equals BC because rhombus sides are equal. So if you like, it's like a square but for a parallelogram. Rhombus sides equal. Although actually a square is also a rhombus, so anyways. And the last thing is that opposite angles in a rhombus are the same, which means that these small angles here will also be the same. So angle NDC equals MBC because the rhombus opposite angles are equal. So honestly, I haven't really seen them use rhombi technically, like a rhombus in a long time. So those facts might not be fresh in your mind. But now the idea is that SAS congruency, because it's two sides and the angle between them. Very interesting. I haven't really seen them use that in a while. The final question is again a slightly easier, not easier one, sorry. It's an interesting one because I don't really know what topic you'd call it. Maybe percentage change, maybe you call it iteration, you could call it all sorts of things. So, the pressure at sea level is 101,325 pascals. Cool. Every 1 kilometre rise decreases the pressure by 14%. So at 3 kilometres the pressure at 14% less than at 2 kilometres. Work out the pressure 4 kilometres above sea level. So what you could do, this is iteration, but just to show you another way of doing it, you could do like sea level equals 101,325. 1 kilometre above equals, 14% times 101,325. 2 kilometres above would be 14% squared times 101,325, and so on until you get to 4 kilometres. But this is basically just an iteration question, but disguised, which is interesting. I would probably at least write the working out, because they wouldn't give you marks just for getting an answer. You don't need to actually get the numbers, you can just write the working out though. You don't need to, belabor the point. That's what we're looking at. And yeah, not much to that question other than that. But again, these types of questions, I don't think the maths was particularly challenging, but again, it's the application that I think a lot of you guys are struggling with. So a lot of people after paper 1 and 2 said to me, outside of the exam, when we were talking about it, I realised what I had to do and it's really easy. And well, that's the problem, isn't it? But it's knowing what to do. It's problem solving that they're really testing here, not really maths. Interesting. Yeah, 38.9 pascals. and that would be it. But other than that, it's probably going to be the last video of GCSE Maths that you guys are going to watch ever, which is very interesting. But yeah, if you do have any questions or have any requests, obviously I'll try and do it by Monday, which would be very interesting, but I'll try my best. But other than that, best of luck in your final GCSE Maths exam, and I'll see you in the next one.